Assalamu alaikum. In this video, we are going to discuss about dimensionless numbers. The videos on dimensionless numbers are uh, are made in 3 different parts, so that we can have a small video and which can be interesting for you. So these are the dimensionless numbers that are discussed in total 3 parts. The first number is Biot number. Biot number is the ratio of conductive heat resistance within an object to that of convective heat resistance across that object's boundary. Mathematically, we can say that Biot number is equal to conductive resistance of a solid to that of convective resistance of fluid. So it's a ratio between solid and fluid. And mathematically we can say that it is equal to H into L divided by K. This number is used, Biot number is used in transient heat transfer and also in extended surface heat transfer calculations. Biot number defines whether or not the temperature inside a body will vary significantly in space while the body heats or cools over time from a thermal gradient applied to its surface. So it tells us about the temperature of a body when there is a heat transfer in that body. So greater the Biot number, more non-uniform will be the temperature field. This is very important, and in many tests, entry-level test or job-level test for chemical engineers, we are asked about different dimensionless numbers, and Biot number is also one of the important dimensionless number for chemical engineers, especially. Also, it's very important for other fields of engineering. So greater the Biot number, there will be more non-uniformity in the temperature, while if there is a smaller number of we have a small number of Biot number, then obviously we shall have a uniform temperature field. The physical importance of Biot number can be understood by imagining an example where the heat flow from a small hot metal sphere suddenly immersed in a pool, and it is immersed in a pool to the surrounding fluid. Now the heat flow experiences two different resistances. The first within the solid metal, and the second at the surface of the sphere. Now if the thermal resistance of the fluid to the sphere interface is greater than the thermal resistance offered by the interior of the metal surface, the Biot number will be less than 1. Now talking about applications, if we have a Biot number less than 0.1 value, it is called the substance is called thermally thin substance, and temperature can be assumed to be constant throughout the metal's volume. While if we have a Biot number greater than 0.1, we call it thermally thick substance, which indicates that one cannot make this assumption, and more complicated heat transfer equations will be required to understand the phenomena, that is heat transfer phenomena, that is going on in that substance, because of the higher Biot number indicates the non-uniformity of temperature field within the material body. The second number is Nusselt number. Nusselt number is the ratio of convective to conductive heat transfer across the boundary. Mathematically, we can say that Nusselt number is the ratio of thermal resistance due to the conduction in a fluid to that of thermal resistance due to convection in that particular fluid. So it is equal to H into L divided by K, or H into D divided by K, and where L is the characteristic length. If the Nusselt number is greater than 1, it indicates that the resistance due to conduction is higher than that due to convection. We can say that conduction is dominant over convection. While we can conclude that in that case the movement of fluid will result in more heat transfer. When Nusselt number is less than 1, it shows the opposite, which means that convection heat transfer is more than that of conductive heat transfer. Nusselt number occurs on liquid surface, while Biot number occurs on solid surface. You can see that the equations of both Biot number and Nusselt number are similar. So the difference is that in Biot number we have a solid surface, we talk about solid surface, while in Nusselt number we talk about liquid surface. Uses of Nusselt number. Nusselt number is used to know whether the natural convection is efficient or not for a particular heat transfer process. And the physical interpretation of Nusselt number is the enhancement of heat transfer due to convection over conduction alone. If, for example, Nusselt number is equal to 1, then the fluid is stationary and all heat transfer is taking place with only conduction. While when we have a Nusselt number greater than 1, the fluid motion is enhanced by convection. The Nusselt number is of very much importance because it contains the heat transfer coefficient information. Sometimes it is also called a heat transfer coefficient, dimensional number for heat transfer coefficient. So it is also one of the very important dimensionless numbers for engineers. The third number is Peclet number. Peclet number is the ratio of thermal energy convected to the fluid to the thermal energy conducted within the fluid. So it is a ratio of L into V whole divided by D, whereas L is we know characteristic length, V is the velocity of the fluid, while D is the dispersion or diffusion. The second definition of Peclet number is the ratio of the rate of advection of a physical quantity by the flow to the rate of diffusion of the same quantity driven by an appropriate gradient. By gradient we mean the difference that causes that particular phenomena. For example, if we talk about heat transfer, the gradient is temperature. If we talk about mass transfer, the gradient is concentration. So there are various forms of this number, and it is very important in the study of transport phenomena when we talk about a continuum. For mass transfer, this number, Peclet number, is defined as the multiplication of Reynolds number to that of Schmidt number. While for heat transfer, the Peclet number is the multiplication of Reynolds number into Prandtl number. So this number, Peclet number, is also called Brenner number for particulate motion. So you must remember these short points for any of your exams, or mostly these numbers are, as I said, very important in different job tests for chemical engineers. The importance of Peclet number. Peclet number is a measure of the relative importance of advection versus diffusion. When we have a large number of Peclet number, it indicates advectively dominant distribution of the fluid, and a smaller number of Peclet indicates a diffusive flow. So it is actually the multiplication of convection transport into diffusion transport. The number tells us about the boundary layer characteristic of the flow, which is related to fluxes of energy. Advection is actually the movement of some material dissolved or suspended in the fluid. Advection, we can say that when something is moved in bulk quantity, we call it advection. So in order to have some advection, we must have something suspended in the fluid. So suppose we have pure water and we are heating it will definitely have convection heat transfer, and there will not be any advection if it is only water. If we talk about pure thing, pure water, pure fluid, then there will be no advection and the flow will be diffusive flow and there will be no advective flow. In order to have advective flow, we must have some solid, something suspended in the fluid. While convection is the movement of a fluid which is in response to heat. Subscribe this channel, like and comment for appreciation and suggestion. Stay united, chemical engineers.